Let's do section 10.4, page 515, exercise 31, which reads, determine the convergence or divergence of the series. Identify the test or tests you use. So for exercise 31, we have the series from n equals 1 to infinity of n squared minus 1 over 2 to the n. Now, I like to use the ratio test, which tells us that we take the limit as n goes to infinity of the n plus 1 order term. So that's going to be n plus 1 squared minus 1 divided by 2 to the n plus 1. And I'm going to divide that by the nth order term. So I'm going to divide it by n squared minus 1 over 2 to the n. And I begin by doing some algebra and simplifying, because that is almost always what I can do with the ratio test. And I'm going to be able to cancel my 2 to the n's with my 2 to the n's up in the numerator, and I'm going to end up with a factor of a half. And that's going to be times the limit as n goes to infinity. And then I'm actually going to expand out my n plus 1 squared term up here in the numerator. So I'm going to have n squared plus 2n plus 1 minus that 1 that I had in the first place, divided by n squared minus 1. This plus or minus 1 are going to cancel, so I'm going to have 1/2 times the limit as n goes to infinity of n squared plus 2n over n squared minus 1. And if we think back to the days when we were evaluating limits originally, one of the things we talked about was end behavior modeling. And because these are both polynomials, I can apply end behavior modeling. And end behavior modeling tells me that my polynomials are going to act as their leading order term. So I'm going to have my 1/2 out front times the limit as n goes to infinity. And these are going to behave as n squared over n squared. But that's going to cancel. So I'm going to end up with a half. Now remember, when I use the ratio test, this term up here, which is the limit as n goes to infinity of the ratio of the n plus 1 order term to the nth order term, that is equal to L. And if L is less than 1, as it is in this situation, that tells me that my series converges.